So now we're going to practice our Ohm's law, and we're going to use it to try and work out the value of the resistors under this piece of wood. And when we've done that, we can lift it up and see whether we're right or not. Let's look at the circuit. We've got a power supply and a voltmeter telling us how many volts we're getting from that supply. We've got an ammeter, and then we come through one of these four resistors, which we select by this switch, and return to the batteries. Let's switch it on. For the very first time, we've got a digital voltmeter and a digital ammeter. And these are rather fun and very, very useful. One of the great things that it's doing is this bottom value here is the number of watts. So it's automatically multiplying the number of volts and the number of amps to tell us the power being used in the circuit. So what I'd like you to do is to record the values that we're getting off this meter for each of the four resistors and try and calculate what the value is going to be underneath. Now you've actually got two sets of values for each resistor, because if we throw this switch, it reduces the number of batteries being used, and we've got a lower voltage and correspondingly a lower current. So we're going to have two sets of values, two attempts if you like, working out the resistance for each of the four resistors. Now if you've got the board in front of you, pause this video now, record the values for yourself, and then you can open this up and actually see whether you're right or not. If you haven't got the board in front of you, we're going to go through each, and you've got the opportunity of working them out for yourselves, and then I'll show you what we've got underneath. So for this first resistor, when it's on low voltage, we've got a voltage of 3.28 and a current of 0.21, and on a higher voltage, a voltage of 6.31 and a current of 0.40. For the second resistor, on that higher voltage of 6.84, we've got a current of 0.2 amps, and on the lower voltage we've got 3.51 and a current of 0.10. For our third resistor, on the low voltage we've got 3.57 and a current of 0.07 amps, and the higher voltage 7.03 and a current of 0.14. And on the last resistor, on this higher voltage, 7.22 and a current of 0.07. And with the lower voltage, we've got 3.66 and a current of 0.03. So pause the video now, use those values to try and work out what you think the resistance is underneath here. Right, let's look at the results. Let's look underneath. The four resistors are 15 ohms, 33 ohms, 47 ohms and 100 ohms. Now remember, the value that you've calculated might be slightly different because these have a tolerance. I think these are within 5%. So the value that you've got may not be exactly these ones here. Now let's just go back to the number of watts that we've got at the bottom here. So for this 15 ohm resistor, we've got a current of 0.41 with this voltage of 6.31, and it's burning 2.57 watts, which is quite a lot. And if I put my finger in here, I can actually feel it getting warm. And that's the reason why we've got these big resistors here, which are rated at taking up to 5 watts. Most of the resistors that we're dealing with are dealing with very, very small values wattage wise, and therefore they can be a lot smaller. They're probably rated a 1/4 watt, 1/2 watt. But because I knew that we were using a lot of current here and they were low values, we've had to use 5 watt resistors.